Ever ponder about the inception of the universe and when life could have possibly appeared in this vast cosmic expanse? Let's take a trip back in time, all the way back to the very dawn of our universe. Picture yourself floating in a sea of nothingness. Then, in an instant, a cataclysmic event occurs. This event, known as the Big Bang, is believed to have set our universe in motion about 13.8 billion years ago. In the blink of an eye, the universe expanded from a singularity, a point of infinite density and temperature, into a cosmic expanse filled with a hot, dense soup of particles. Matter, energy, time, and space as we understand them today were all born in this momentous event. But this was just the beginning. As the universe cooled and expanded, particles came together to form atoms. These atoms, predominantly hydrogen and helium, were the building blocks of everything we see today. They clumped together under the force of gravity to form the first stars and galaxies. This period of star formation is known as the Cosmic Dawn, a time when the universe transitioned from darkness into its first light. The birth of stars was a crucial step in the universe's evolution. They are the cosmic furnaces where heavier elements like carbon and oxygen, essential for life as we know it, are synthesized. But stars alone weren't enough. It took another billion years or so for the first planets to form. These celestial bodies, born from the dust and gas around young stars, provided the stage upon which life could potentially play out its grand drama. Yet, the universe in its fiery infancy was not yet a hospitable place for life. The conditions were too harsh, too volatile. It would take billions more years, countless cosmic events, and a whole lot of patience before the universe would be ready to cradle life. The universe in its fiery infancy was not yet suitable for life as we know it. After the Big Bang, it took a while for the universe to cool down and for the first stars and planets to form. This wasn't an overnight process, mind you. It took approximately 400 million years for the first stars to burst into existence, a period known as the Cosmic Dark Ages. Imagine a universe filled with clouds of hydrogen and helium floating around in the dark, waiting for gravity to weave its magic. Over time, these clouds started to collapse under their own weight, giving birth to the first generation of stars, or as astronomers like to call them, population 3 stars. These stars were massive, much larger than our sun, and lived fast and died young. As they exhausted their nuclear fuel, they collapsed under their own weight, triggering a supernova explosion. These cataclysmic events were more than just cosmic fireworks. They were the cosmic forges where heavier elements like carbon, oxygen, and iron were created, elements that are crucial for life as we know it. Meanwhile, the universe was not just cooking up stars, it was also busy crafting planets. Dust and gas swirling around young stars began to stick together, forming planetesimals. Over millions of years, these planetesimals collided and merged, growing into full-fledged planets. But not all planets are created equal. For life to form, a planet needs just the right conditions, a sort of Goldilocks zone. It needs to be at the right distance from its star, where it's not too hot and not too cold, allowing liquid water to exist. It also needs a protective atmosphere to shield it from harmful cosmic rays. So in this cosmic kitchen, the universe was busy preparing the ingredients for life. It took a few billion years, but eventually these elemental building blocks were in place. Stars had seeded the universe with the necessary elements, and planets offered a home where these elements could come together. It's these elemental building blocks that set the stage for the possible emergence of life. So, when exactly could life have first appeared in the universe? It's a question that's provoked heated debates and countless theories among scientists for years. One of the most widely accepted theories points to a period known as the Late Heavy Bombardment, around 3.8 billion years ago. This was a time when our planet was subjected to a barrage of asteroids and comets, creating conditions that may have been conducive to the emergence of life. Amidst the chaos and destruction, the building blocks of life like amino acids and simple sugars could have been synthesized, giving rise to the first life forms on Earth. But what about life beyond our home planet? Could it have emerged elsewhere in the universe? This brings us to the captivating concept of astrobiology, the study of life in the universe. Scientists have identified several potential locations within our own solar system where life could exist. Mars, for instance, with its history of water, is a prime candidate. Then there's Jupiter's moon, Europa, and Saturn's moon, Enceladus, both of which are believed to harbor subsurface oceans. These are environments where life, as we understand it, could potentially thrive. Beyond our solar system, the possibilities become almost infinite. With an estimated 2 trillion galaxies in the observable universe, each containing billions of stars and potentially habitable planets, the probability of life existing elsewhere becomes a tantalizing prospect. Yet despite our best efforts, we've yet to find definitive proof of life beyond Earth. It's a puzzle that continues to baffle us, but it also fuels our curiosity and our relentless quest for knowledge. It's a journey of discovery that might just prove we're not alone in this vast cosmos. So, as we gaze up at the stars, we're left with a humbling realization. Life, it seems, may not be unique to Earth. If life could have emerged so long ago, where is everybody else? This question is at the heart of the Fermi paradox. Named after physicist Enrico Fermi, this paradox grapples with the apparent contradiction between the high probability of extraterrestrial life and our lack of contact with such civilizations. Imagine this. There are billions of stars in our galaxy alone, many of which are similar to our Sun. Around these stars orbit countless planets, some of which are likely to be in the habitable zone where conditions might be just right for life to exist. And our galaxy is just one of about 2 trillion galaxies in the observable universe. When you consider these staggering numbers, it seems almost inconceivable that we are alone. This leads us to another important tool in our quest for extraterrestrial life: the Drake equation. Developed by Frank Drake in the early 1960s, this equation provides an estimate of the number of civilizations in our galaxy with which we might be able to communicate. It takes into account factors such as the rate of star formation, the fraction of those stars that have planetary systems, and the likelihood of life developing on those planets. But even with all these astronomical numbers, we are yet to make contact. This doesn't mean we have stopped looking. On the contrary, our search for extraterrestrial life is more relentless than ever. We have spacecrafts like the Kepler and the TESS missions scanning the cosmos for potentially habitable planets. We have the SETI Institute using radio telescopes to listen for signals from intelligent alien civilizations. And let's not forget about the recent discoveries. Just a few years ago, scientists detected potential signs of life on Venus in the form of phosphine gas. And the discovery of water in the form of ice on Mars opens up exciting possibilities for life as we know it. So, where is everybody else? We don't know. But what we do know is that the universe is vast, and we are still searching. The search for extraterrestrial life continues to be one of the greatest adventures of our time. The universe is vast and we are still searching. What does the future hold for life in the universe? As we gaze into the cosmos, we ponder the infinite possibilities that await us. One thing is certain: the universe is teeming with potential for life. A multitude of planets orbit their stars in the Goldilocks zone. Not too hot, not too cold, but just right for life as we know it to exist. Scientists believe that there may be billions of Earth-like planets in our galaxy alone. Could some of these celestial bodies be home to life forms waiting to be discovered? Only time and further exploration will tell. But what about us, the human race? Will we ever set foot on other worlds? The prospect of colonizing other planets is no longer a mere figment of science fiction. Ambitious projects are already underway to make human habitation on Mars a reality in the next few decades. If we can overcome the formidable challenges that lie ahead, we may one day become a multiplanetary species. And what of our own planet, Earth? As we forge ahead into the future, we must also safeguard our home. Our survival hinges on our ability to navigate the challenges of climate change, resource depletion, and other environmental crises. Only by harnessing sustainable technologies and reimagining our relationship with the natural world can we ensure a future for life on Earth. But let's go beyond our galaxy and think even bigger. What does the future hold for the universe itself? According to cosmologists, the universe will continue to expand indefinitely. Trillions of years from now, all the stars will have burned out, leaving behind a dark and desolate cosmos. But even in this somber scenario, there's a glimmer of hope. Quantum fluctuations could potentially give birth to new universes, spawning new stars, new planets, and perhaps new life. As we continue to explore the cosmos, who knows what we might discover next? The universe is a mystery waiting to be unraveled. The future of life in the universe is an open-ended question, an enigma as vast and as wondrous as the cosmos itself.